In this video, let us talk about various types in Java. Basically, we have two categories of types. So primitive types and we have the reference types. So primitive types are just for storing atomic values and reference types are used for storing complex objects. Now let us first discuss about primitive types. So for this, let me create a simple table. So primitive types. So in the first column we have type. Then in the second column, let us say we have size. And this third column, we have the range for that data type. So first is byte. Now byte takes 1 byte of memory. And the range of values that lie within the byte type is -128 to 127. Second, we have the short type. Short takes 2 bytes of memory and the range for the short values lie from -3 to 768 to 3 to 767. Next we have the int data type. Now the variable of an int data type takes 4 bytes of memory and the range for the values is -2147483648. So it lies somewhat around in the range of 2 billions to 2147483647, and this is a comma. Now you can see for the integers the value ranges in billions. Next is long data type. So long takes 8 bytes of memory and the value ranges from -9 to 23372368547758808 to 9223372368547758807. So all the above types are used to store numbers that do not have decimal point. If you want to store numbers that have decimal point, so for them we have the float and double data types. Now variables with float data type takes 4 bytes of memory and variables with double data type takes 8 bytes of memory. Next we have the char data type. So let me write this here. So float 4 bytes, double 8 bytes. Then we have the char data type. So let me write this here. So char type, and this is used to store a single character and this takes 2 bytes of memory. And finally we have the Boolean type. So let me write this here. So Boolean, which is used for storing Boolean values which can be true or false. So let us head over to the editor and try some of these primitive types before we discuss about reference types. In the basics.java file, let us create a bunch of variables, and the idea here is to use appropriate data types based on the size of the data. So let us define a variable and name it as weight in kilograms. So what data type should we use here? Should we use an int data type? Let me know in the comment section down below. So the answer is no. We should not use integer data type for a person's weight, and the reason here is that the person can have a weight of 60.5 kilograms as well. So storing it as an integer will remove the decimal part, which definitely we do not want. So we will store it as a data of type float, and float data type, as we know, takes 4 bytes of memory. So let us define it as a float variable and give it a value of 60.5. Now here, if you can correctly see, it says type mismatch cannot convert from double to a float representation. Now 60.5 is a floating point number, and all the floating point numbers are represented by default as a double value. So in order to convert it to float, we need to use suffix right after the value. So we can say capital F or a small f, and using this suffix we mark it as a float. So by explicitly specifying them as float by using the f suffix, we convert a double value of 60.5 to a float value, right? Now let us see the character data type in action. So just a while back, we discussed that character data type is used to store a single character and it takes 2 bytes of memory. So let us define a variable of type char. So char English character, and set that to capital A in single quotes. Note that you always surround characters in single quotes and multiple characters or strings in double quotes. Now let us discuss about Boolean data type. So a variable with Boolean data type can have only one of the two possible values, true or false. It is just like a switch. So let us define a Boolean variable. Boolean is eligible to vote and set this to false. Now make sure to use a descriptive name for the variable so it conveys what exactly it stores. And now let us print all the variables to the terminal. So system.out.println weight in kilograms, system.out.println English character, and system.out.println eligible to vote. So now we are done with primitive types. So let us give this a whirl. So Java C basics.java and Java basics. So now you can see we are getting 60.5 capital A and false being logged to the terminal. So now we are done with primitive types. Let us move forward to reference types. Now reference types are those types that store complex data objects like a custom user object or date object, for example. Now let us understand reference types with the help of an example. Now in Java we have a date class which is present in util package of Java, inside which all the utility classes and methods are defined. So let us import this at the top. So at the top you can see the import java.util.date. Now let us name the instance today. Now here we need to use the new keyword to allocate memory for our variable of type date, which is today in this case. Now using the new keyword makes the difference between a primitive type and a reference type. When declaring data of primitive types, we don't need to allocate memory for primitive types. The allocation and releasing of memory is handled by the Java runtime environment. Contrary to this, for reference types, we should always allocate the memory. We don't have to deallocate this memory for reference types. The Java runtime environment will automatically take care of that. Now coming to our code, we say new date. Now in this example, the variable today we define here is an instance of the date class. So this date class defines the blueprint for creating new objects of type date. Now these instances that we create or the class itself have methods that we can access using the dot operator. So today dot. So on the date instance we can access methods like getTime, hashcode, toString, from. Let us print the date instance to the terminal. So system.out.println today. So let us compile our code and run the file, and you can see we are getting Monday, September 28 and the time and the year. Now here comes the second difference between primitive types and reference types. Primitive types do not have methods defined on them. So if we try to access English character, which is a primitive type, and we apply a dot on this, you can see we are getting no methods on the primitive type, which in our case is a character, because primitive types do not have methods defined on them. But on a reference type like the today instance that we just created, on applying the dot operator, you can see all these methods that we can apply on the instance. Also on the class, which is also a reference type, you can apply methods like UTC parse on the date class. So this means that reference types can have methods on properties defined on them. Now lastly, let us go over the memory map for both primitive types to be crystal clear with the differences between primitive types and reference types. Let us first consider an example for primitive types. So let us first define a variable number 1 and set this to 23, then another variable number 2, and let us copy the value of number 1 to number 2. So here you can see we are copying the value of number 1 into number 2. In this example we have two different variables, number 1 and number 2. So let me show you the memory map. So in this example we have two different variables, number 1, let us define a location for this, and number 2. So say number 1 is sitting at a memory location 0x100 and number 2 is sitting at memory location 0x102. Now both these numbers are sitting at different memory locations, so they are completely independent of one another. So in other words, if I change the value of number 1, number 2 is not going to get affected. So on running the line 20, 23 gets stored inside number 1, and then we are copying the value of 23 in number 2, and both of these variables are independent of one another. So now if we update number 1 to 42 and if we print number 2, then number 2 will remain unaffected. So let us check this out. So first update the number 1 to 42 and let us print number 2 to the terminal and run the file. And you can see number 2 didn't got affected because both number 1 and number 2 are completely independent of one another. But if we do the same thing for reference types, then the behavior is entirely different. So let us create 2 date objects and try doing the same thing for them. So reference types, date, date1, new date, and then date, date2. Now here comes the interesting part. When the JRE executes line 26, it is going to allocate some memory to the date1 object. So let us say this is our memory location, and this is our date1 object sitting at a memory location of 0x100. Next, for line 27, it is going to allocate a separate part of the memory to the date2 object. So date2. Let us say that date2 object is sitting at a memory location of 0x200, and here on line 27 you can see we are assigning the address of the date1 object to date2. So what happens in this case is that inside date2 we have the address 0x100 and the date2 object is sitting at an address of 0x200. So the date2 object will store the address of date1 object, which we assumed to be 0x100. So here on line 27, unlike primitive types, we are not copying the values of the date objects, but instead we are copying the address or the reference to the date1 object in memory. That is why they are called as reference types, because they do not store the actual values, but instead they store the references to the actual objects in memory. So in this example, date1 and date2 are referencing the exact same object in memory, which is sitting at the memory location 0x100. We only have one data object in memory, so let us say this, and this is sitting at 0x100. So both date1 and date2 references are pointing to the exact same object in memory. So we only have one object in memory being pointed to by these two references. Now there is a simple trick to verify that whether both the references point to the same object, so we can access the hashcode method on both of our references. So system.out.println date1.hashcode, and let us do the same thing for date1 object as well. So date2.hashcode, and let us compile the code and run the file, and you can see we are getting the same value for both the references, which means that both the references point to the same object in memory. So both these references, they are not independent to each other, and you can use any of these two to mutate the object, because both of them point to the exact same object that is sitting at memory location 0x100. So the changes made by one reference on the object will be visible to the other reference as well, and vice versa. So this was all I wanted to cover in this video. If you liked the video, do give it a thumbs up or comment down below if you have any query. Don't forget to subscribe to the channel, and let's catch up in the very next one.